Okay, so question 6. Logic gates. Yay! Hopefully nice, easy marks. Okay, logic gates are, I find, quite fun. It's like doing a Sudoku puzzle or something. But anyway, we have this expression, x equals a and b, or b and not c. And we have to draw the logic circuit. It must have 2 inputs, so if you go into OUC, you can have multi-input gates. And do not simplify the logic expression. So don't try and make this into something more efficient. That's not what they want. They want you to draw it out exactly as it is on there. Okay, so we'll get 3 inputs, A, B, C, and we'll get an output, X. I'm going to use the logically.ly / demo because it's quite a cool site. Just to do it, so I've got A, B, and C. And I could label those if I wanted to with A, B, and C. And we're also going to have, at the end point, we're going to have X. Okay, and X is going to be my little light bulb here, so it's going to be on or off. Okay, so let's go here. Now, here we go. So we've got our brackets. Now, just like in any other system or maths, brackets come first. So like PEMDAS, BODMAS, whatever you want to call it in maths. We also have an order of operation for logic gates. So we should have nots, then ands, then ors. So if for some reason they don't have the brackets, you should apply your nots first, where possible. Obviously, outside the brackets, it's going to be harder. We're going to have nots where we can, and then we're going to apply ands, and then we're going to apply our ors. So let's try and draw that. So A and B. So let's start with that first bracket. A and B. It's just going to look like so. A and B. Okay, and then we've got, in the other brackets, we've got B and not C. Okay, so I've got and and not, so I should do the not first. So let's do not C. Not C. Okay, and B and not C. So we need another and we're going to connect B and not C. And then finally, we're going to connect those 2 lines together with an OR to give us X. So we apply our OR gate, doom, doom, and then let's move X a bit closer. And so I believe that that is going to be the answer to that question. Again, it's one of these things you kind of just got to learn, you've got to just go with and practice it. But remembering the different orders of operation can be helpful at times. Okay, and let's pop that onto my paper for the next question. Okay, so then we need to complete the truth table given the various logic. Okay, so well, first of all, I'm going to copy that question just so that for completion. And put that above my thing here. Okay, so then I want to go here and I want to do this table. So basically, I have got to make the table to go with the diagram that I've just made, or to go with the logic statement that was there as well. Now, what I would do is I would start by going into my diagram, and I would label the gates inside of it. Okay, now like I say, let's do nots, then ands, then ors where we can. So I'm going to call my not here, let's call this one, so A, B, C, D, and then A and B, let's call that E. Let's call this one F, and then this one, the output is going to be X anyway, so we don't need to worry about that. So we're going to need 1, 2, 3, 4, 5, 6, 7 columns on my table. And that's the whole point in the working space. So if you've got a table like this, really you should then, in the working space, draw in the new points that you've done. What did I say? I think I said 7? 7 by 9. Let's go by 7 by 9. Okay, now hopefully I've not messed up. But we've got A, oops, I've got A, B, C, D, E, damn it. Oh yeah, do I? F, and finally we've got X. Okay, so I've got this table, and hopefully I can start to fill in my different values. Now, as you notice here, the numbers are just the numbers in binary. So the first row is 0, 1, 2, 3, 4, all the way along until we get to 7. It's important, if you don't have this information given, that you do it in this order, because that's the way it's going to appear in the marking scheme. And also just make sure that you can, make sure you have all the combinations. Okay, so that's every combination. So that's 1, and then 2, and then 3, and then 4, and then 5, and then 6, and finally number 7. Okay, so our first one is easy enough. So I've said that D is not C. So all I have to do is take my C value, and in a NOT gate, it becomes the opposite. So it's going to be 0, 1, 0, 1, 0, 1, 0, 1, 0. Okay, so with, let's make this a different color just for, so with a NOT gate, we change the, it looks disgusting, but still, yeah, with a NOT gate, whatever we put in is changed to the opposite. So a 1 becomes a 0, and a 0 becomes a 1. Nice and easy. Okay, our next one we said is going to be E, which is A and B. Now, quick reminder, an AND gate, when we have A and B into an AND gate, 0, 0, 0, 1, 1, 0, 1, 1. Oh, wait. Delete row. Delete row. Okay, so when we have 0 and 1 into our gate, 0, 0 in an AND gate, so both things have to be true in an AND gate for the output to be true. So our table would be 0, 0, 0, 1. So basically, the only situation where we get a 1 is where it is a 1 and a 1. Now, in this case, we are comparing A and B, so we just need to look down our table and say, is there anywhere where we have a 1, 1? Ah, here and here. The rest of the situations, it's all not the case. So here we can put in 1, 1, and we know that everything else up here is going to be a 0. Now, F is a little more tricky. So F is an AND gate, but we're not comparing A and B, we are comparing B, and very importantly, not C. So not C, we already did, and not C is called D. Now, the place where a lot of people make mistakes is just following, comparing the right line with the right line, because it can get a bit tricky to take it in charge. So we're comparing B, I hope. We're comparing B with our D here, okay? So unfortunately, you can't really color things in very well on the exam, but hopefully, just for the video, you can see here. Now, the rule we said was, it must be a 1, 1 to give us a 1. Every other situation, it's a 0. So let's see, 0, 1, nope. 0, 0, nope. 1, 1, aha. Let's put in a 1. 1, 0, nope. 0, 1, nope. 0, 0, nope. 1, 1, yep. 1, 0, nope. Okay, so everything else can be put in as a 0 at this point. Okay, and then we have finally, we have our x, right? Which is our OR gate. So for an OR gate, and in this case it's going to be EF. So we're going to have E and F in an OR gate. Now what are the rules for OR gates? For an OR gate, if any of these is on as a 1, then the output will be a 1. So that's going to look like this. Okay, so in this way, when we're doing an OR gate, we probably want to do it the other way around. We want to look for 0, zeros and set them to 0 and set any other condition to be a 1. And this time we're going to be checking. And this time, oops, I'm making a mess here. Oh my god. Oh, it's just because it's not seeing the highlight. Okay. Transfer. Or not. Okay, that's maybe not working. Oh, it did. Okay, and this time we're going to be comparing E and F. So again, picking the right ones to compare is generally where most people end up going wrong. Now, again, our condition is 0, 0 will be a 0. Everything else will be a 1. So let's look down here. 0, 0 is going to be a 0. 0, 0 is going to be a 0. 0, 1, don't care. 0, 0 is going to be a 0. 0, 0, 0. 0, 0, 0. Okay, and then all of the other ones should therefore be 1s. And that here, this x, should hopefully then be the correct result from my working space over here, or sorry, because in the truth table over here. Okay, now let's check and see. So I've drawn it in here. So one useful thing if you're playing around with this is that you can generate a truth table. So false is 0, true is 1. So they've got it as 0, 0, 1, 0, 0, 0, 1, 1. Okay, and we've got 0, 0, 1, 0, 0, 0, 1, 1. Okay, so I'm lucky that I can double check against that, but for you, you're going to have to just get confident and don't be afraid to write out the truth tables for the ands, the ors, nots, the XORs. Just writing them out can really help you sort of keep it in your brain. Yeah, I mean, like I said, the biggest mistake is usually people look at the wrong column. Okay, and